Hi Lou, see what you think about this. We're looking at the number and sum of the divisors of some whole number. Now, this uses the unique prime factorization theorem. So there's the unique prime factorization of some number n. And from that we can get the number of factors, which is related to the exponents that the primes are raised to. And the sum of the factors is this horrendous looking object. So what we're trying to see is a way of picturing this so that those two formula make sense. So let's take a specific example, 72. Prime factorization is 2 cubed times 3 squared. And using the formulas, we'd find that the number of factors is 12, and the sum of the factors is 195. Let's see whether we can get a picture of this so that we'd have some idea of how to actually prove those two formulas. So 72, that's 8 times 9. Those are the powers of the primes. So let's make a rectangular array of balls that's 8 by 9. Now, that's 72, and 72, there's one of them, so that is a factor. So we've got a factor 72, and we've got 72 toward the sum of the factors. Now we can start breaking these up. Powers of 2, we can just start taking halves of each one. So here's 8 divided by 2, which is 4, and 4 times 9, 36 is another factor. So here we have two factors we've shown, and we're on our way to the sum. Now, since we're dealing with powers of 2, we can go ahead and break the 4s into 2s, and here we have 4 times 18. So 18 is another factor. So now we have 3 factors, and we're getting toward the sum. And notice that's 2 plus 4 plus 8 times 9. We can divide the columns one more time, and we end up with 9 as a factor of 72. Now we can't divide the columns anymore, so we go over to the 9, and we see that 9 is 3 3s. So we have another factor, 3 times 8. Now we can start doing the same process we did before. Divide the 8 in half. So now we have the factor 3 times 4 are 12. Divide the 12 in half, and we end up with 2 times 3. And divide again, and we end up with 1 times 3. So we've generated 8 of the factors, and note that we've got a rectangle, so it's fairly easy to see how many we have so far. It's 3 plus 9 times 1 plus 2 plus 4 plus 8. So we're starting to get something that looks like the sum of the factors formula. Now, we can't divide the 8 anymore, so let's go to the next factor of 9, and we're at 1. Each one of the 3's can be divided by 3 to get 1. So now we have the factor 8. And we do the same process we've done before, divide that in half. We get 4, we get 2, and we get 1. Now, if we look carefully at this figure on the right that we've developed, we can see that there are 12 factors, and the number, if we look, we have 1 plus 2 plus 4 plus 8 times 1 plus 3 plus 9, which is the sum of factors, the formula for the sum of the factors. And this basically is just a massive distributive property application. And the number of columns of different factors, you have a column over 1, 2, 4, and 8. And this is just 3 plus 1, and it's generated by the exponent. Since it's 2 cubed, we have 4. 0, 1, 2, and 3 is the exponent. And the same for the rows. Each one of the rows is generated by the powers 3 to the 0, 3 to the first, 3 squared. Finally, we can look at all of the different factors. So number of factors is 3 plus 1 times 2 plus 1 are 12. And you can see that those are the number of boxes. And the sum of the factors, we're just looking at a rectangle. Now, what happens if we have 3 primes? Well, we're going to go into 3 dimensions, and we're going to have these things piled on top of each other. Four prime factors, four prime factors are going to get us into 4th dimension, which would be a little difficult to picture. It's possible, but very complicated. And if we only had one, say 2 cubed, then we'd just have a line, but it would still follow the formula. Now, here are the different factors and how they relate to each other. You can see that each one of these represents a factor. If we look at the number of balls in each rectangle, bottom right is 72, bottom left is 9, and we can pick one in the middle, say there's 3 by 4, which is 12. So these are all the factors, and the unique prime factorization theorem could be used to show that those are the only ones you could possibly have. So we have them all, and this shows why the formula for the sum and the formula for the number of divisors makes sense.